Okay. Good morning, everyone. My name is Kip. I hope everyone has a good day. Everyone had their coffee this morning, and we are ready to start. Okay. So let's start off. Okay, these presentations is compiled actually to discuss the critical challenges faced by our global airline industry, but our main focal point will be in a Malaysian perspective, which has been further complicated by the emergence of COVID-19. Okay, the first outbreak of COVID-19 in Wuhan, China, back in December 2019, has actually uh, damaged the industry into a new disastrous new low records. Okay, we have seen that the overall reductions of 50% of seat offer by airlines. Then we also seen that contractions of 2,700 millions of year-on-year passenger carried, and there's approximately $372 billion of losses from most of the world airline operating passenger operating revenue. Right? There's so how we go. So this presentation will arrange in 4 sections. First, we'll see the section 1, which is the macroeconomics and microeconomics, the complexity of the airline industry. Then sections 2, we'll have the challenges in the airline industries, and section 3, which is the solution and the actions plan to address the highlighted issues, problem, and weaknesses. Then the last sections will be concludes with the future industry outlook and expectations for the COVID-19 recovery. Section 1, the microeconomics and macro and microeconomics. Okay, so you can see the graph there. So the global aviation industry has been facing a severe headwind, such that many airlines are contemplating between a business profitability and sustainability, including our homegrown Malaysian carrier. Okay, we can see that total 46 airlines has ceased operation back in 2019, followed by 43 airlines in 2020, and to make matter worse, approximately 11 other airlines also suffered the same fate in 2021. Okay, this example further exemplified the gravity of the industry downturn, and the governing body of IATA suggested a mixed outlook across a different region, basically due to the different pace of vaccinations and the international border control and travel restrictions irregularity. Generally, the airline industries undergo a rapid development through a series of boom and bust cycle, whereby the airline profitability usually repeat itself in a periodic cycle of 10.5 years for the global industry standard. The airline profitability factors cannot be determined consistently. It can be endogenous, exogenous. Okay, put it simply, it's just a very market-oriented sector that hinges on the cost allocations, capacity adjustments, and the dynamic between the supply and demand. So how COVID-19 affect the airline industry? Nobody actually expected the COVID-19 to stay for that long, okay? Because previous major global events such as the 9/11 or 2008-2009 global financial crisis, which overlapped with the H1N1 pandemic flu, has resulted in temporary grounding. And you can see from here, this is the major event compared to COVID-19. This is COVID-19. Okay, 1 month after the 9/11, the industry capacity declined by 15%, and it actually just took 12 months to rebound and overcome the public fear to fly again. And the global financial crisis also slashed minus 13% of seat capacity compared to the previous year. And the industry actually took 12 months to recover, which is these two, shown by these two graphs. But for the COVID-19, the industry actually stumbled to its lowest point in the history, which is down by 83%. You can see this line. And it is obvious the airline is not out of the wood as the Omicron variant is still rampaging, and the recovery we can expect will be extended and tougher. This is the impact of the COVID-19 shown on this dip in the graph. Okay. So where does the industry stand now? The global economy activities has been showing positive improvements on the back of the vaccine and the significant inoculations of the population in emerging markets. The Bank Negara Malaysia actually estimated that Malaysia economy to expand 3 to 4% GDP year-over-year for 2021. There's also sign of economic rebound because there were improvements in the labor market and the export sales and the manufacturing sales. Okay. The increase in the GDP will usually translate into increase in income per capita, therefore increase in consumer confidence index. However, this is not reflected in the airline as industry-wide revenue passenger kilometer remain significantly down for much of the financial year 2021 as a result of the travel restrictions that kept the number of passengers carried low, particularly in the international travel. So this is the graph. Secondly, the domestic travel is the key for airline recovery. In the month of September and October 2021, the passenger traffic actually increased by 56.6% and 190.2% month-on-month respectively. This represents about 5.3 and 14.9 of passenger movement recorded in the same month during the pre-COVID periods. The catalyst for the passenger traffic improvement in September and October was spurred by the ease of interstate travel restrictions, the reopening of Langkawi domestic travel bubble, and the increase of flight frequency between the East and the West Malaysia. The recovery was further supported by easing of the health protocol, such as the removal of the quarantine and the negative swab test results. Subsequently, we can see several airports around Malaysia has actually seen increment of passenger market share for the month of October 2021. This is the graph of the passenger traffics. So there's actually increment of passenger traffic in the major airports such as Kuala Lumpur, Langkawi, BKI, and Kuching. So what have we learned from the Langkawi travel bubble? The consumer survey conducted between the February and May 2021 actually revealed a very significant informations, where 60% of the correspondents actually confident about traveling domestically despite the COVID-19. For a start, Langkawi travel bubble was tried in the mid-September, has seen the highest passenger growth compared to the other Malaysian airport. The uptrend continued into October with a record of 261.4% of month-to-month of increment. With this, it can be deduced that the Langkawi passenger traffic has recovered 79.1% of the pre-COVID level. Airline in Malaysia actually rushed to increase their flight frequency to Langkawi, arising from this travel bubble initiative. Okay, 87% of the traveler actually believe there is a balance between the health risk and the need for an economic recovery. Next, we have seen advantage for country with big domestic market. Similar passenger traffic recovery pattern can be observed with country with bigger domestic market, high vaccinations, and adaptive precautions government policy in handling the COVID-19 situations. Example, in North America. North America are forecasted to return to profitability by 2021. You can see here, their reduction in capacity is, their increase in capacity is sooner than the rest of the regions. Okay, in Asia Pacific, China domestic passenger traffic actually reached around 115 of pre-COVID level in April. In 2021, but has fallen to approximately 77% in October 2021 due to multiple clusters of localized outbreak across the country. In contrast, Middle East dependent on the international market actually will see prolonged period in the passenger traffic recovery. So the key takeaway here is airline which is based in a country with bigger domestic and short-haul regional market poses slight advantage than the others in order to increase the seat capacity sooner for the revenue generations. So there's a benefit for countries with big domestic market. So the upward momentum of passenger demand actually lags behind the increase in the airline seat capacity, meaning to say passengers are reluctant to fly despite the airline is already increasing their flight frequencies and seat capacity. For the year 2021, the global airline has increased seat capacity offering by 20%, despite the overall load factors only stands at 68%. The airline industry worldwide has incurred losses of $324 billion in 2021, after the back-to-back losses of $378 billion in 2022. Reason being, the airline is facing difficulties to fill up their seat due to the rock bottom passenger demand since the pandemic. The stagnated demand in air travel gave rise to the low load factor performance, although airline has already improvised by cancelling high number of seat capacity. Essentially, there will be a downward pressure on revenue for airline to bring down the average ticket fare in order to stimulate the demand growth. However, this is not exactly what happened in Malaysia. The average fares has increased by 15.4% year-on-year in 2021, which translated to roughly 317 ringgit per ticket compared to 275. So we can see actually Malaysia ticket fare increased despite the demand. Clearly, the high pricing of ticket fare will suppress the price-sensitive passenger to fly. This complex situation actually put the airline in dilemma. It's either to cut capacity or to reduce the fare pricing at the expense of the airline profits. Previous experience shows that cutting capacity is not ideal, as operating costs will rarely decrease in tandem with the capacity reductions due to the high airline fixed and overhead costs. Likewise, the reduced airline capacity means less flight frequencies, more aircraft will be on ground, which do not benefit airline in terms of profit generation activity, but instead will incur more losses in parking fee, extended maintenance downtime, potential loss of profitable traffic rights, and takeoff and landing privileges slot at the major airport. Excessive cutting capacity will also paralyze airline industry such that they are unable to ramp up sooner to capitalize on the return of the pent-up demand. You can see this is just a very short window for airline to actually increase the seat capacity because of the spike in demand for traveling. So the questions remain, how should airline utilize its capacity in the most efficient and productive way? Next, we see the optimism of the air cargo business. Unlike the airline passenger business, the air freighter industry ride on the opposite faith. The cargo ton kilometer (CTK) is a measurement of the freight carrying capacity. Observe a surprise increment of 7.9 for the period of January till July 2021 in comparisons to the performance in the year 2019 for the same periods. That indicated CTK has surpassed the pre-crisis peak in August 2018 by a significant 5%. During the pre-COVID, the air cargo was unexciting, it's dull and monotonous, often regarded as a secondary business activity. Nonetheless, the air cargo big global good trades for much of the 2021, a common indications signaling that the economy is rebound, the economy is returning, whereby the business turned to the air cargo to rapidly stock up the inventory. Other factors which contribute to the air cargo business includes reductions in the passenger aircraft cargo belly capacity, and the bottleneck in the global supply chain dynamic, especially due to the exceptional longer supply delivery time, shortage of the sea freighter container, the seaport congestion, and the expensive fare for the other modes of cargo transportations. Moving into 2021, the price for the air cargo has stabilized after peaking at the year-end winter. In fact, the rate has dropped 17 to 30% since. This mathematically, the spread between the air cargo and the sea freight, for example, is even narrow and less obvious, and that does not count into the speed differential and the reliability of the delivery. As we all well aware, the movements of the price and humidity-sensitive cargo, such as vaccine, PPEs, and medical supplies, are becoming more important in time of the COVID-19. So we can see here, this is the important figures that we have quotes for the air cargo business. The cargo business performance for March of the 2022, although the industry CTK actually increases by 7.9, the actual CTK was below 12, minus 12.4, indicating there's room for more cargo capacity additions. The airline financial health. The airline business is actually a very rough business environment because while running on the high fixed costs with a very thin profit margins, the industry ecosystem is very volatile and is often subjected to multiple variables that will affect the profitability. Example, the fuel price, foreign currency exchange, political instability, pandemic, natural disaster. These are just a few examples. The airline industry net operating losses have widened to more than minus 80% in 2022, year of year. By 2021, rallying behind the strength of the air cargo business, some airlines did actually manage to offset the loss in the passenger revenue. You can see a big dip here, where the airlines are suffering losses in revenue. All in all, the industry-wide is still posting the operating losses of 20% in revenue, and the airline also faced the challenges to actually stop the blip and to turn profitable, albeit the slow in the revenue growth. Indeed, many have actually resorted to restructuring or move forward plan for business consolidations. See, it's still a very big dip over here. The airline has actually been accumulating a high level of debt since the beginning of pandemic. The debt figure actually raised by 23% from $250 billion in 2022, in 2020 to $340 billion in 2021. A very heavily debt-ridden airline is actually highly leveraged and are very susceptible to bankruptcies, and not to mention constraint in the cash in hand to actually serve the debt financing due to the high interest rate environment. However, looking at the optimistic side, some airline has actually raised, global airline has actually raised $63 billion in bond and loan in 2021, and indications of the returning investor confidence in the aviation industry. Once the business traveling and the tourism activity actually allowed to resume freely, taking into account the current situations whereby thousands of aircraft are actually still grounded. This amount of emergency capital, although it's just a tips of an iceberg, does indeed provide a much relief buffer for the airline to cushion through the bumpy roads. Here are some examples of the airlines that have successfully raised new capital injections from the market. Strangely, the amount of emergency funding raised during the pandemic period has been refinanced at lower interest rate. You can see lower interest rate, the interest rate is coming down, which with a more manageable tenors. Even so, airline must be mindful to keep that the debt level control, because study has shown majority of the airline operating on a very thin liquidity, which is about less than 5% of the normalized revenue. Hence, any industry shocks will actually cause significant distress that will land the airline in the deeper trouble. Okay, that's when we come to sections 2, critical challenges in the airline industries. Number 1, business continuity. And we further break it down to fuel costs. About 2/3 of the operating expenditure of an airline are the fixed costs, and one of the major expenses is fuel. The changes in the fuel in short term can swing wildly a flight from being profitable to a loss depending on the price of the crude oil and the number of passengers carried. Fuel actually account for 19.5 of an airline operating expenditure. 19.5 is actually an underestimate value. Today, with the current fuel price, this percentage is actually higher than 19.5. The global price in the crude oils has increased steadily since 2020. Compounded by the Russian conflict in Ukraine, this has created an upward price reactions for the fuel supply shortage in the market. The situation is actually unfavorable for the airline because profitability of the airline is often correlated to the fuel of course, such that the decline of fuel will actually contribute to the higher increase in airline profits. We can see here in 2015, 2017, 2015 to 2017, whereby the fuel costs were lower, which is approximately less than $75 per barrel. The airline actually recorded some profits. So back in 2028, when the fuel price was high at 147, we can see that the airline actually suffered some losses, drop in their profits. So at present, with the average fuel price at 162 USD dollar per barrel, that is today, I just checked this morning, it is $162 per barrel. The global airline are estimated to burn $71.7 billion in footing the fuel bill, or which is representing approximately 45% of the airline total operating costs. This report was based on Malaysia Airline reports. While the cost of flying continuously trending lower as a result of competitions and globalizations of internet, which create ticket price transparency, the cost of operating an aircraft is actually on the rise, which will inadvertently slice the profit margins of an airline. So you can see here the price of the fuel is climbing since 2020, and this is February 2022. And they actually climbed even further here now. Then we also have the labor issue. The IATA actually highlighted two elements of expenditure that will dent the airline profitability. First was the earlier on, the first mention was the fuel, and the second is actually the labor. The labor costs amounted about 30.9 for an airline operating expenditure, and this figure has actually increased to 31.1 in year 2021. While initial payroll support program from the individual government has managed to keep the staff employment temporarily, eventually the airline reduced total employment headcount from 2.93 million in 2019 to 2.48 million in 2020, which represent a decline of 18.8% of the employment year on year. As a result, the labor shortage in the skilled and the semi-skilled category actually contribute to the wage inflations, which is also reflected in unit per cost increase from 0.123 to 0.18. The retrenchment also magnified the severity of immediate labor shortages. From the bigger perspective, staff absence actually crippled the airline operations, especially during the peak holiday season, which saw many as 59,240 flights cancelled worldwide. The number actually increased sixfold in comparison to 2019. and 2.5 times more than year 2020 total of the flight cancellations. In terms of operational challenges, the airline may resort to slash 10 to 20% seat capacity because of staff shortages. How can we right-size the fleet to meet the demand and capacity? Because airlines are facing difficulties to tailor their overcapacity to meet the sluggish passenger demand. Although demand for the travel does bounce up occasionally, however, it is nonetheless very short-lived and seasonal orientated. Flying an aircraft with low occupancy is equivalent as burning cash in the sky. Coupled with the highly controversial proposed social distancing practice in the aircraft cabin, it is almost impossible for most airlines to achieve break-even load factor of 77%. Study has shown that airlines at least must meet a load factor of 77% to break even your flight. Meaning to say your cabin must be filled 77% of an aircraft seat capacity to break even your operating costs. Depending on the type of the aircraft and the seat configuration, social distancing in the flight can actually reduce the seat capacity by 33 to 50%. Let me show you the illustrations. Okay, we all know that a 3 to 3 seat configurations will have the middle seat emptied, while the regional turboprop aircraft with 2 to 2 seat configuration will see 1 passenger allowed per row on each side of the house. So it is estimated social distancing, if it is enforced in flight, will actually reduce the bookable seat to only 62% of the normal capacity. Remember, 77% compared to 62. There is a very huge gap for the airline to fill in order to break even. That's why one of the quickest way for the airline to alter their capacity is to right size their fleet. There is a catch. Downsize the aircraft fleets to reduce number of smaller size aircraft might be tricky, because when it comes to travel demand surges, when the pandemic is brought under control, can the airline actually accelerate fast enough to add capacity to capitalize the opportunity? The key to the fleet management decision priority is the versatility of the airline, versatility of the aircraft and the fleets. Why? Because the airline needs the capability and efficiency of the new technologies at the lowest cost and risk. For example, the airline are no longer interested to bet on the wide body that can only serve a small subset of the network. Likewise, the narrow body that cannot be scaled up and be profitable in terms of the cost per unit seat. That's why in the long run, the airline industry will require a balanced load factor between the wide body and the narrow body that can offer attractive flight distance under the lowest trip and seat cost altogether. And of course, ladies and gentlemen, that's where my fellow engineers and technologists can come in and play our part. New competitions. How does the intensity of the airline competitions evolve over the pandemic era? Like the old saying, in time of hardship, one may find a new opportunity. Recession and economic shock can be the best time to start a new airline with strong balance sheets, given the investor backing for financial support and the availability of the great aircraft purchasing and leasing deal. Malaysia has actually seen 2 surprise airline startup during the pandemic era. One is the rumors My Airline and SKS Airways, which operate on the Twin Otter for the island hopping tourism industry. Is competition necessary? To some extent, yes. The healthy competition is essential for the equilibrium and the expectations of the market for product and services. Airlines also face challenges in human factors and performances. Okay, more than 70% of the aircraft incidents recorded are often associated with human factor error. Indeed, it is more susceptible for human to commit an error than an aircraft failure. Okay, these are some of the branches of the study of human factors. And take the COVID-19 into account, the COVID-19 has actually interrupted the human performance in many senses because of the series of idling activities, health isolations, economy shutdowns, and rush, um, and the airline actions to rush to return to service. Here's why. Staff may feel not safe and in control of returning to workplace because they are under stress due to anxiety, employment uncertainty, salary reductions, and because of fear of COVID-19 infections at the workplace. Human fatigue because due to the staff shortages, some staff may actually forced to work or to take on additional workload. Work environment and dynamic, job reassignment to a different sections, departments, team arrangements may affect the people's ability to work more collaboratively. These may aggravate the problem with deviations from the correct procedures due to peer pressure or group behavior. And we also have complacency, which is a human habit of taking things for granted. So remember the Murphy's Law, we always take that as anything that can go wrong will always go wrong. Then we also see skill degradations due to the lack of practice, because muscle memories says to be diminished over the time with the lack of practice. So these are examples of the aircraft incident that relate to the human factors and performances. This one and this one. Safety in the sky and ground. Flying has been part of a modern lifestyle, and getting on board of the aircraft is among the most safety activity in our daily life. The global airline industry safety metrics for year 2021 was mixed in comparison to 2020. Last year, out of the 26 cases of incident and accident involving aircraft, 7 were fatal. That's one jet and 6 turboprop aircraft, which saw an increase from 5 in 2022. Meanwhile, the total number of air fatality decreased from 132 to 121 for year 2021, with average count of 204 within the 5 years. The accident per million flight also showed tremendous improvements from 1.58 to 1.01. So based on this data, it is fair to conclude that the airline transportation is indeed the safest way of traveling. In retrospect, until the root cause of the recent 737NG China Eastern flight is revealed, there is still always a public skepticism for the airline safety. So safety is everybody's responsibility and utmost priority. It is frequently connected to the airline brand value and unique selling propositions. Despite all these statistics, the airline safety and security has been subjected to the intense debate, including several unforgettable turn of events that destroy the public confidence. Here are some of the examples. So, is the 737 MAX design flaws issue have finally been resolved? So we see these are the two incidents and accidents that we are very fond of that actually attract lots of the public attentions. Then we also see congestions of the global air traffics. With the number of aircraft flying increase each year, the air traffic is becoming overutilized and suffering from the severe conditions of air traffic congestions that magnified into issues such as excessive fuel burn and chronic air and noise pollutions, especially to the communities around the airport areas. Inefficiency in the air traffic management will also contribute to the high number of flight cancellations and delay, incurring unnecessary costs and time of traveling onto the passenger. Ground conditions, Ground congestions actually presents risk of aircraft to aircraft or aircraft to vehicles collisions due to the minimum separations in between that limit the freedom of maneuverability. Bear in mind, the air traffic congestion does not purely originate from the aircraft alone, but other flying vehicles such as helicopters, glider, air balloons, and now the threats from drones. 14 April 2020, you can see here a 350 collided with the Emirates 777 in Dubai. It is appeared that the 350 struck the left side horizontal stabilizer of the 777 while pushing back for departure. The brand new 350, nearly a year with service with British Airways, suffered damage to its horizontal stabilizer. Both aircraft have to be grounded for structural damage assessment. What could be the factor causing the incident? Human error, tarmac congestions, or rushing for early departure to make the time slot? Another example here. The Ryanair 737-800 actually collided into 3 units of parked fuel bowser positioned on the side of the ramp apron when a tow bar broke and separated while the aircraft was being maneuvers. Very interesting. How come there was no any cockpit personnel inside the aircraft during the towing procedure? And could it be lack of experienced staff, human error, or the ground equipment failure? Next, we see the airline financial pressure during the pandemic has seen many operational and technical staff were retrenched and furloughed as part of the restructuring process. With the reduced headcount, airlines are scrambling to operate the flight to meet the market capacity under out of normal circumstances, not to forgetting the importance of the skilled and experienced staff in handling of the crisis. This is a thought for everybody. Well, and organizations become less safe and more risky with inexperienced staff. Okay. The airline also faced some wildlife threat in the airport. The slowdown in the air traffic during the pandemic has seen the increased presence of the wildlife habitations around the airports. Their presence, especially the avian creature and the insect, endanger the aircraft operations, especially increased likelihood of bird strike during takeoff, landing, and the wild infestations of the aircraft opening and gaps. Under worst possibility, bird strike can cause structural damage and engine failure in flight. So recall US Airways Flight 1549, an Airbus 320 which struck a flock of birds and eventually suffered double engine loss shortly after takeoff, the Hudson River incident. And there's another one. The Etihad Airways Airbus 330 was forced to make an overhead emergency landing in Brisbane after what was believed to be a mud double wasp nest infestations on the aircraft speed sensor. The wasps can build sizable nesting within 30 minutes around the peripheral of the small hole and openings, which potentially obstruct the freedom of airflow into the aircraft pitot static and the total air temperature probes. This is the pitot probes and the wasps filling up the nest in the small gaps and hole of the pitot probes. The airline also faced challenges due to the airspace safety due to the war conflicts. The civilian airspace around the large part of Ukraine, Belarus, and Moldova is closed for commercial flight after Russia initiated a military operation onto Ukraine. EASA, the aviation's governing body, warned airlines to avoid the particular airspace, including Russia, as fear for the increased flight safety risk, whereby widespread use of military ground and airborne weapons and equipment can be fatal to the aircraft operating at the various altitude and flight levels. Many flights were cancelled, suspended, and diverted, arising from the localized war conflicts. This is the example of the Japan airline. Japan Airlines normal flights take about 9,850 kilometers and average duration of 12 hours journey to fly from Tokyo to London. This is the original route, Tokyo to London, represented by the white line. But because of the war and the conflicts in Ukraine, Japan Airlines actually have to travel over 13,000 500 kilometers on a 15 hours flight, passing over Alaska, Greenland, and Iceland prior to arriving to London from the west, which is represented by the red line. With this reluct, Japan Airlines actually incur additional flight operating costs in terms of fuel, crew expenses, aircraft rotation downtime, and to a certain extent, increase in the carbon emissions into the environment. And last, we have not forgotten the tragic event of the MH17, where the 777 with 298 people on board shot down by the missile in Ukraine airspace when it was flying from Kuala Lumpur to Amsterdam. At the time of the event, there were active military activities between the Ukrainian force and the pro-Russian separatists. We also see increment in weather conditions such as ice formations. Ice formations on the wing airfoil causes loss of lift and increase of drag for the aircraft. Loss of lift during flight due to the disrupted airflow is unwanted because aircraft actually develop tendency to stall. In any event, ice formations can also freeze and jam the flight control surface such as aileron, elevator, and rudder, which affect the control of the aircraft in roll, pitch, and directional attitude respectively. Besides that, blizzard also reduces visibility during the aircraft maneuvering on ground and in air during holding patterns approach for landing. Another one will be microburst and wind shear. Microburst and wind shear are a series of strong up and down draft within the cloud which give rise to the extreme velocity and rapidly changing direction of the local gush at the flight low altitude. As takeoff and landing are critical, aircraft encounter with wind shear is undesirable as it will alter the flight path significantly. So the aircraft will experience sudden uprush or downrush. Sorry. The last one will be the crosswind, where the high velocity crosswind is dangerous to aircraft, such that the wind may affect the aircraft flight path and attitude during critical flight phases, especially during takeoff and landing. You can see the aircraft experience strong crosswind. This is what sometimes they call a crash landing. And this is one of the latest issue for the airline safety, radio signal interference in the sky. The deployment of the 5G facilities operate in the frequency bandwidth C-band, about 3.4 GHz to 4.2 GHz around the vicinity of major airports are said to be interrupting the aircraft low-range radio altimeter, short form LRRA system. Coincidentally also operate in a range of 4.2 to 4.4 GHz. The radio altimeter system actually measures the radio height of the aircraft up to 8,500 feet. Radio altimeter input signal is used in various aircraft systems such as autopilot, autothrottle, and decision height setting. As more 5G towers are built around the world, where the radio altimeter signals interfere and jeopardize the safety of the flight. See from here, 5G tower and radio altimeter interference. The airline also faces challenges to decarbonize the industry for more environment sustainability. The tremendous pace at which the air transportation is growing has drawn the wide attention from the various parties in relation to the negative impact of the airline operations on environmental sustainability issues such as climate change, air, water, and noise pollutions. The huge consumption of the burning fuel by the aircraft has contributed to the increase of greenhouse gases. Environmental awareness that lobby for the anti-flying companies have magnified when many people choose not to fly on aircraft, instead opting for a cleaner mode of transportation. The survey conducted revealed 20% of the air traveler in the US and Europe has reduced the air travel by minimum a flight in the past year because of the rising concern for the climate change. If these flight shaming trends continue to spread, airline business is forecasted to be hit by the slow growth in the passenger traffic, hence adding more pressure to the passenger GU. Can be seen here what happened before and after the Greta effect. Greta Thunberg's one of the child environment fighter, hardcore fighter that champion for the flight shaming. This is the number of years that the fossil fuels are expected. Not much left. Okay, we come to section 3. So emerging from the post-pandemic, there are two identified strategies that airline can undertake to restore its resilience. One, the airline need to repair the balance sheets with a steady cost-saving initiative. And two, to sustain the robust capacity growth via resource optimizations. As our team implied today's, these sections will actually focus more on the engineering and technologies innovations with the main focus of cost and capacity that will likely put the airline back on track for profitability. So the airline actually needs to make use the wonder of the data science and the big data. The human interactions with the modern world has left behind billions of terabytes of digitalized data and leads, often being overlooked as a valuable source of intelligence. What if this data is actually extracted to provide insight and forecast for the business improvements? Through the data science, the raw data is actually collected, grouped, filtered, and processed via the data analytic technique such as modeling, testing with the algorithm, and finally clean for the interpretations. The data analytics can reveal the market trend and key metrics which aid in optimizing the workflow processes and overall efficiency of the business. For instance, the data analytic provide accurate real-time informations, especially when the airline require broad analysis of the flight frequencies on different route networks that are loss-making. Data such as infection rate, flight restrictions, and travel sentiment combined with the predictive analysis will enable the airline to anticipate the losses more accurately. Doing so allowed the airline to evaluate the feasibility of each flight undertaken and availability of working capacity to sustain the future operation ahead of the time. Likewise, to attempt a realistic measure to cut down the losses, such as to suspend the route, downgrade to a smaller aircraft, or proceed with interlining and cost sharing with the partner airline without losing your market share. Data science is also effective in foreseeing the trends in the ticket booking and cancellations by different categories. This includes scenario simulations under various circumstances, whereby what if future demands rebound for a specific customer segment, product expectations, and their willingness to pay. Customer respond to the market, such as active credit card activity, and the uptrend in the customer online spending for flying are also indicative of the customer confidence towards travel resumptions. Experienced airline can then use the data-driven analysis, can alter their strategic management to pinpoint the geo-specific interventions for the maximum return of investment. Knowing the purchasing habit of their customer base, airline can configure their 4Ps, product, price, promotions, and the place of distribution to increase the sales conversions. The innovative big data approach will not only contribute to increasing airline revenue by driving ticket sales and at the same time to provide opportunities to generate ancillary revenues through upselling and cross-selling of the core products. Similarly, applications of the big data complement the airline initiative for cost saving. The fuel costs represent approximately 24% of the airline overhead costs during the pre-COVID. Therefore, any measure to save fuel consumption is significantly to increase the airline profitability. The modern aircraft fleets are equipped with multiple computers and sensors are able to measure and profile the optimum flight characteristics that correspond to better fuel efficiency. These informations are particularly useful in time of the flight planning for network expansions and negotiations for fuel hedging policy with the supplier. The big data also support the airline maintenance program. Collaborations with the airlines and the manufacturer on joint developments of the on-time maintenance software, which preemptively gathered aircraft intelligence such as flight parameters, component faults, and engine trend patterns, will help in airline planning of maintenance actions and supply chain distributions. Again, the intelligence assists in planning preventive maintenance and forecast of the inventory replenishments that actually save the airline approximately $13.3 million yearly in service interruption, recovery, and the repair costs. This is indeed a big data at your fingertips, provided it is applied in a more strategically and smart uses. Airline will exhibit competitive advantages and the unique value propositions over their rivals. In short, the data science can help the airline to save costs by prioritizing spending on necessary and productive activities. Then we go to sustainable aviation fuel. The alternative sustainable aviation fuel is the biggest prospect for reducing the aviation emissions in the future. The sustainable aviation fuel is a hybrid biodiesel which is composed of a mixture of domestic feedstock and a traditional fossil fuel. Currently, all the sustainable aviation fuel used is a blended up to 60 to 40% by ratio. Sustainable aviation fuel is capable of producing 80% less carbon emissions compared to the Jet A1, hence making sustainable aviation fuel a direct and more environmentally friendly resources to fuel the future aircraft. Presently, the production stands at a marginal 0.02 of the global demand, which is so insignificant to produce any impact of decarbonizations of the economic of scale, necessary to reduce the cost to a competitive level. IATA project the sustainable aviation fuel productions must reach at least 5 billion liters in 2025, which represent 2% of the global demand, and gradually scale up to cover at least 5% by 2030. What's holding back sustainable aviation fuel? Airlines are making high-profile commitment to use sustainable aviation fuel, but it can be seen overall industry adoption still remain very low compared to the fossil fuel. The cost of implementations, the cost of implementations, shortages of the technologies, expertise, and infrastructure are said to be some of the biggest challenges for the smooth transitions. So this picture shows Malaysia Airlines flight 7979 and Airbus 330-200 departed from the Amsterdam using a blend of approximately 38% of sustainable aviation fuel. Some interesting facts about sustainable aviation fuel. The airline also needs modernizations of the aircraft fleets and new design. The route to decarbonize aviation industry take another notch up, with many airlines use the opportunity during the COVID-19 slump in travel demand to optimize and upgrade their existing fleets by retiring the aged aircraft and switching wide-body to narrow-body fleets, and by investing in a more modernized and fuel-efficient new generation aircraft. Embracing the new technology, especially investment in the modern aircraft, will promote innovations that introduce higher quality level of product and services and enhance functionality for the airline demanding customer. Airline must be critical and creative in implementing the incremental innovations of the basic products, such as improving, upgrading the product dimensions typically valued by the customer, such as refresh of the cabin appearances, in-flight entertainments, and the provisions of Wi-Fi on board. This graph actually shows different aircraft with respect to their fuel efficiency. So a quad engines aircraft normally are less efficient compared to a twin engine aircraft. While the long time wide body flight was considered a luxury, the tide has actually changed and airlines are actually struggling to fill up the seat with the wide body. Hence, many small aircraft such as the 737 MAX, 787 and the Airbus 321 are preferred. This plane exhibit a lower fuel consumptions per kilometer flown, lower noise emissions due to twin engine design, and their lightweight reinforced airframe has enabled the airline to mount non-stop long-distance route more economically, at which passengers enjoy the value of one flight convenience. Modern plane design provide lower ratio of surface area to high volume of fuselage, which enable flexibility in configuring the cabin seats to accommodate higher capacity without compromising the passenger comfort and the maximizations of the cargo belly hold utilizations. Then, because of the modernized new aircraft fleets, airlines is able to exercise their network rationalizations to scale up their business model accordingly. The effort to cost cutting and increase efficiency has prompted airline to switch over to the hub and spoke, which is this one, the one in highlighted in yellow, model rather than the point-to-point network. This is a point-to-point network. The hub and spoke enable the expansion into a larger geographical area through rationalizations of route and concentrations of air traffic from the hub. The hub and spoke work wherein passengers are fed from other regional to the center hub prior to transiting to the next destinations. As a result, the hub and spoke will serve more destinations with fewer routes as displayed from the above example. The above example display 5 destinations will require 4 connecting routes with a hub. In contrast, 10 routes will be needed if a similar destination are connected point-to-point network. See, the illustration is from here. Hub and spoke will be able to serve. It is pivotal for the airline to exercise. It is pivotal for the airline to exercise, number 1, sensibility in selecting the aircraft fleets that met their business model and the future growth strategy. Number 2, it is difficult to fill seats for wide body, so airlines don't require too many wide bodies aircraft. Modern narrow body is capable of doing a long distance route that was previously reachable by the wide body, but at a more economical operating cost. The fuel consumption is 30% less than the previous aircraft model. On top of that, turboprop aircraft like the ATRs and the Dash 400 can provide a marvelous fuel efficiency alternative to the jet aircraft over short distances, point-to-point regional network. Number 4, aging fleet should be put to storage or for early retirement due to incompetent fuel consumptions, additional weight due to corrosions, airframe contaminations and skin repair, and high maintenance costs. Because it is estimated a heavy airframe maintenance check and a twin engine overhaul can cost up to $16 million per hangar visits. We have seen improvements in the aircraft designs that have offered large saving in overall. Some of the innovations that we have seen on modern aircraft over the past few years, such as wingtip devices. From the aerodynamic point of view, the main purpose of the wingtips is to reduce the induced drag, a combination of skin drags and the pressure drags. Due to the tapered design, which is this one, for the wing from the root to the tip, the magnitude of the induced drag is more severe towards the end. For the aircraft, any drag is not desirable, and it jeopardizes the flight performance in terms of the fuel burn and the loss of lift force and thrust. The wingtip installations benefits the aircraft in many ways. reduce fuel burn, increase maximum range, reduce takeoff fuel length, increase cruising altitudes and speed, reduce takeoff noise. Sorry. This figure actually illustrates the many types of the winglet design and the effectiveness in reducing the induced drag during the flight cruising. The considerations must be taken into account for the wingtip device installations may constitute increase in the aircraft gross weight and structural load limitations. Irrespective of which type of the design are favorable, there is no clear-cut answer, but rather the bottom line objective that the designer aims to seek will be either for fuel burn efficiency or maximum range, taking into account the weight penalty and the total drag reductions. Most of the aircraft of the modern aircraft we can see are fitted with a wingtip devices. How about this one? Shark skin inspirations. Nature has also inspired the aviation industry in many ways. For instance, it's not just the bird that has solution for the aerodynamic and aerofoil. Likewise, the sea creature shark also being replicated for some of their streamlined evolutions. Now, the sharks are also making a big wave in the aviation industry. The Harvard Universities and its partner observed by incorporating a denticus, which shape look like a shark, skins, structures on the aerofoil design can potentially increase its aerodynamic performance by up to 323% through modifying various combinations of size, pattern arrangements, row and positions. The denticus mimic the protruding micro crest and trough of the shark skin, assessed to enable efficient airflow over the airfoil, which subsequently create additional energy to supplement the momentum loss in the boundary layers. As a result, the optimum lift to drag ratio can be generated. By far, two German aerospace engineering have pioneered the state-of-art laser technology that actually engraft the denticus, or what they call riblets, onto the top surface of the aircraft pans. These riblets can reduce the aircraft drag by 10%, which translates to approximately 1% of fuel cost saving, amounting up to $1.5 billion annually. You can see the Lufthansa Cargo pioneered the application of the shark skin technology on its first 777 freighter in the year of 2021. It is estimated that the airline will be able to achieve the annual saving of 3,700 tons of fuel and nearly 11,700 ton reductions of carbon dioxide emissions, which is equivalent to 48 individual freighter flights from Frankfurt to Shanghai. With all the modernizations, the airline also needs to reinvent the aircraft fuselage and the wing. In comparisons to the aluminum alloy as the aircraft skin, the composite material is actually excellent in high strength to weight ratio, which is about 30 to 50% lighter, corrosion resistant, and high durability to impact, as well as non-susceptible to the metal fatigue stress. The modern aircraft utilizes the composite material widely, from a small panel to a huge component like a wing, fuselage, contribute to the total reductions of the aircraft gross weight, which benefits the airline in return of extra payload, improved fuel efficiency, and additional flight distance. The applications of the composite in aero manufacturing does come with a catch. The aircraft fuselage is built in pieces by pieces in barrel from a different supplier. It is very likely there will be a dimension imperfections and tolerance during the final assembly. One of the common defect flaws observed from the composite structures, especially on the fuselage joint sections, will be the improper size shim used to fill in the gap as a result of uneven flatness on the inner fuselage skins along the joining circumference. We can see a modern aircraft of Airbus 350 utilizes about 52% of the composite materials. About half of the aircraft are built from composite materials. So this is one of the new technique that we have seen in the composite manufacturing, which is known as high pressure resin transfer molding technique. This method starts with a very careful method and mix injected high pressure resin into the preformed fiber in a mold, which subsequently subjected to pressing and curing over the time to achieve the desired shape and integrity. In a certain case, the induction heat mold can be used to cut the cycle time as much as 50% shorter. The obvious benefit of this technique compared to the ordinary technique are shorter cycle time, higher fiber contents per part, allowed precision fabrications. This model of aircraft, the ICAT MC-21, built using this HP RTM technique, high pressure resin transfer molding. And this one, the Airbus 220, which was manufactured in Northern Ireland, Belfast. Another one is thermoplastic composite technique. The multifunctional fuselage development program under the EU Clean Sky Initiative pioneered in the productions of an 8.5 meter long fuselage skin made entirely out of thermoplastic composites with the automatic fiber placement fabrications. This was a prototype built with thermoplastic composite technique. Thermoplastic is unique, unlike thermoset, in a way that it can be heated and reheated multiple times to achieve the desired uniformity and bonding. On top of that, thermoplastic composite manufacturing allowed for bigger parts to be built in one piece convenient due to it lighter in weight compared to aluminum alloy. Thermoplastic eliminates standard fastener and dustless joining by welding, hence saving thousands of rivets, bolts, and nuts, which led to dramatic reduction in the total weight. From the maintenance perspective, ramping up the production is an achievement, but quality and accuracy of the end products must live up to the expectations. It will be a laborious job to do manual inspection for quality control. Therefore, a new generation optical infrared wave sensor has been developed to accurately measure the length and successfully cut down the processing time by up to 30%. Of course, other NDT techniques such as eddy current, radiography, ultrasound will still remain relevant in performing the composite structure inspections. The airline also needs a future engine design, which is capable of delivering more fuel efficiencies, power, and reliability to operate an aircraft for an airline. The Rolls-Royce has successfully built the world's largest turbofan engine, also known as the UltraFans, measuring over 12 feet or 144 inches in fan diameter. Its power gearbox will be the spotlight, so powerful that it can transmit power of 87,000 horsepower or 64 megawatts, more than the entire grids of the Formula One cars when running at the maximum RPM. The UltraFan engine family can be used on both narrow body and wide body and is poised to deliver 25% fuel efficiency compared to the other Rolls-Royce series. Another plus point, the UltraFan is compatible to be used with sustainable aviation fuel as a direct replacement, hence making it more environmentally friendly in reducing the carbon emissions. Anyone heard of this spirit of innovation projects? The Rolls-Royce is also making a leapfrog progress in the electric engine propulsion system with these spirits of innovations projects. Here you can see the first prototype, a fully electrical powered propeller aircraft, is producing zero carbon emissions with recorded top speed of 556 km per hour over a distance of 3 kilometers. Realistically, this will pave a new horizon for the future electrical vertical takeoff and landing vehicle for 2 to 6 passengers and a potential small electrical commuter aircraft that can fit in 9 to 19 passengers to fly the regional routes. Well, challenges remain to be tested. As the aircraft size gets bigger, can the electrical powered battery operate an engine to sustain a flight of that size? Like the automotive industry, can hybrid electric propulsion tweak the changes? A total zero emission flight powered by battery is only possible and commercially attractive when the battery cells used as a single pack unit can supply up to 400 watts per hour per kg. Up to this point, there is no other any battery capable of giving that energy density as a jet fuel. For comparison, it is estimated 200 to 220 watt per hours per kg of battery packs are required to fly 4 to 6 passenger loads over 100 nautical miles. Besides that, there is also a safety concern of using high voltage system at the high altitude operations. The low pressure environment during the cruising actually degrades the electrical resistance of the insulation material. Coupled with the water condensation formed at core temperature, there is a possibility of short circuits which could trigger fire on board. As technology and innovations advance, there is always more room for improvements. CFM, liquid hydrogen fuel engines. Ongoing, the CFM has also partnered with Airbus in developing the hydrogen as the next alternate fuel source to power the world's first climate neutral zero emissions commercial aircraft. Dubbed as the Project Zero E, the two will use the passport engine. This is the basic GE passport engine. As a passport engine as a basic constructions whereby the various modifications and upgrade will be done to facilitate the usage of the liquid hydrogen fuel. The GE passport engine is selected due to its compatible size, advanced turbo machinery and capability to operate at a wide range of pressure and temperature in accordance to the different phases of flight. Despite the prospect, using a liquid hydrogen fuel presents a big engineering challenges, especially when it comes to harvesting its energy density. The hydrogen exists in a simple gas matter, and to carry the sufficient amount of power to a standard flight will take a huge storage space on board. Therefore, it is more likely that hydrogen gas will need to be condensed into a liquid form for storage and reheated again to vaporize into gas for fuel combustions in the engine. And let us not forget, the hydrogen is also a very combustible in nature, and any mishandling will present a fire hazard to both the aircraft and passenger on board. What is the prospect of the liquid hydrogen engine? Liquid hydrogen fuel engines for a greener environment. In order for the hydrogen to decarbonize the aviation industry, it has to be green in total of the supply chains, meaning to say the green hydrogen must be produced with a renewable source, solar or wind, in a more sustainable way. These illustrations shows how the green hydrogen is produced from a renewable sources for aircraft next alternative fuel. Next, we will see the airline will need a creative aircraft cabin innovations. Reason being, despite the public escalate fear and skeptic to chances of getting a COVID-19 infections in the aircraft cabin, the industry expert actually rebuffed the myth and reaffirmed that the aircraft cabin is actually cleaner than one can assume. Modern commercial aircraft is equipped with high efficiency particulate A HEPA filters in the aircraft air conditioning system, which block and capture 99.97% of the airborne particles over 0.3 micron in size. This efficiency of this filter, perhaps counterintuitive, increases for even the tiny particles, non-exceptions to the size of the SARS COVID-19 virus. The aircraft air circulation is so impressive, whereby the existing air is renewed almost every 3 minutes at the proportions of 40% filtered air by HEPA and 60% renewed air from the outside atmosphere. From the aircraft maintenance point of view, it is important that inspection and maintenance work for the HEPA filter should be carried out periodically, as a broken or dirty filter may compromise its effectiveness. Next, we also see some changes and innovations in the cabin cleaning and disinfections. Airline has taken initiative to up their cabin cleaning and disinfections as precautionary to prevent transmissions from contaminated surface or objects with physical contact and sensory inhalations. Disinfections of the aircraft cabin can take variety of methods, ranging from simple wipe-off with solution, spraying, misting, and to some extent using a delicate UV light to kill germs and virus. Here we can see the UV ones offer the convenience and portability that can be extended to disinfection use at the hard-to-reach compact areas such as the cockpit and passenger seats. This is the UV one. A laboratory installed with UV light for disinfections, considering the laboratory is one of the riskiest sections on board of the aircraft that may contribute to virus transmissions. With the number of innovation and sustainable solutions for aircraft disinfections to improve the hygiene on board, it is hopeful that the passenger confident for flying will eventually return to the pre-pandemic demand. Cabin seating innovations post-COVID-19. Is it practical or just an idea kept? This, known as Janus, the avio interior company from the Italy, the aviation's interior company from Italy has actually proposed a new seat design which reverses the middle seat so that it faces the back of the aircraft and simultaneously separate the adjacent passenger with a transparent guards that enclose the side and the back of each seat. Hypothetically, this would prevent one from spreading germs or viruses to passenger on either side, even without practicing social distancing. You can see a guard is installed that separate the three passengers. The second design is called a glass safe. Maintain the current existing seat design, but installing a transparent shield guard installed between each passenger that covered from the shoulder up. You can see a shield guard is also installed in the shape of a U. This version is exposing one arm, making them susceptible to contact with neighboring passenger in the likely situations where both are battling for the middle arm rest. Despite all this futuristic seating design, are airlines willing to pour in a hefty investment for untested product, which solution can be a very short term, not forgetting the cost and labor force for modifications as well as the hassle to getting approval for the new LOPA. Perhaps another cost caution solutions will be equally effective, such as replacing the aircraft upholstery, seat cover, armrest, tray table with antimicrobial material that stave off the virus, germs, and bacterial growth to an acceptable safe level. The airline also needs advancement in the air traffic management. The severity of air traffic congestion is becoming more apparent, especially during the peak hours in the major airport that handles hundreds of aircraft simultaneously. The global airspace offers no room for errors. A slight blunder invites huge consequences, and to certain extents, it jeopardizes the safety of the aircraft and life on board. Hence, it is paramount to create an airspace that emphasizes on a high level of safety, efficiency, and flexibility for the future air transportations. You can see this is a proposed air traffic management, which is based on a set of trajectories for aircraft which are represented by demand or capacities, refer to each airport on-time capability to handle the aircraft at one time. Okay, this is how it's demonstrated. The black color represents the flight that have already arrived. The red are still airborne. The light greens are the incoming flights, and the dark greens are flights that are delayed departure time. The airport acceptance rates are represented by the white bar. With this new system, it is hoped that they will be able to manage the air traffics in the future, which is simulated by the second diagram. This technique is also called adaptive compressions in a time-based operations. Safety in the skies also require another system to be installed on board of the aircraft, which is known as the ADSB, Automatic Dependent Surveillance and Broadcast. So the basic of the ADSB involve tracking and surveillance of the aircraft based on the satellite navigations and the other sensors installed on board. Various informations can be sent by the ADSB to a different user, such as the ATC as a replacement for the secondary surveillance radar for flight tracking and planning, and other aircraft to provide vertical separations, situational awareness, and conflict resolutions. The ADSB is automatic such that it requires no pilot interventions for activations, and dependent. Two main computers that perform the ADSB functions are GPS and the Mod S transponder. One prominent ADSB application in air traffic has revolutionized improved accuracy, visibility, and real-life reporting of the aircraft present positions. ATC controller can then guide the aircraft into and out of the congested airspace with a smaller minimum separations, hence save time required for the aircraft to obtain the traffic clearance or being instructed for holding patterns and spacing interval. ADSB form an integral part of the time-based operation in solving the air traffic congestions by improving long-term flight efficiency, particularly minimizing the get-to-get travel time and increase the runway utilization capacity at the busy airport. This is the concept of the ADSB, satellite, and the equipment installed on board, such as the GPS receiver and the Mod C transponder with relations to the ground facilities. This is the last sections of the presentations, which is the industry outlook and the expectations post-COVID-19 brought to recovery. First one is the future of the air cargo business. One positivity that we can observe from the uncertainty of the COVID-19 in the aviation industry will be the reinvigorations of the air cargo business. Despite the worldwide grounding of the aircraft fleets, cargo aircraft continue to supplement the airline revenue by generating $128 billion, an increase of 10 to 15% compared to the pre-crisis time. Riding on this momentum, many airlines resort to think out of the box by innovating new way of doing business. For example, introducing P2C, passenger to cargo flights, cargo in the cabin flight, or adding new freighter aircraft to the fleets to meet the demand surge, or retrofitting the existing aircraft into the full cargo operations, also known as the passenger to freighter conversions. Even with a quick airline reaction to add new cargo capacity into the market, the global airline cargo capacity remains shrunken at 21.1% compared to 2019. This indicates there is still void and gap in the cargo market, and that's where the potential revenue may be. One question remains: will the cargo business remain robust once the passenger aircraft belly space return? We all will have to be very wary of the potential of the cargo business in the future once the passenger aircraft belly space return. were we able to sustain the new momentum like how before the COVID and after the COVID? Economic key driver will be airline need to embrace on digitalizations. How digitalization has assisted the airline? The airline needs to be both competitive and to be shielded from operational related risks. In the age of the IR 4.0, airline industry must capitalize on the digital transformations to minimize the current economic downturn while looking for potential opportunity for revenue diversifications. New emerging technologies offer tremendous latitude for cost optimizations and revenue generations. Prior to the pandemic, airline benefited from digital tools that facilitated direct and indirect revenue growth, cost optimizations, and passenger travel enhancement. The results were outstanding. The airline revenue doubled, and the overall industry grew by 10% for a period of 10 years since the digital inceptions. Here, what we can foresee, the digitalization can reshape the future airline industry. See how digitalizations have helped the airline industry in various examples here and here. 87% of travelers support a secure digital system to manage their health credential. A survey conducted among travelers from 11 countries shows an encouraging results that passenger willingness to use secure mobile apps to manage and declare health credential for smooth and seamless air travel experience in the futures. Arising from the pandemic crisis, airlines are not only to rely on digital transformations for business turnaround, but more importantly, the urgency to accelerate the rate of adaptations for continued sustainable business operations. The accelerations of the new capability will enable the airline to develop a scalability of competitive advantages, thus ability to push the value product and service to penetrate the market, to quickly capture the market share. In short, the airline must transform to become more lean and agile to be more relevant. Digitalizations will also help to implement automations in most of the business processes of an airline. Next, the airline needs the government policy to reopen the border. There is a growing consensus within the scientific community that the COVID-19 is here to stay, and that all the imposed elimination strategy and close approaches by many countries are no longer impossible if the global economy is poised to rebound. One way or another, we have to learn to live with the virus. Keeping that in mind, it is important the government to manage the risk as well as to gradually open the border to e-commerce travel at a calibrated pace that based on the progression's milestone. Here are some of the proposed steps that can be taken by the government together with the corporations with the various parties to reopen the borders at a more calibrated and safe manner. Next, we have financial aids and a friendly stakeholder policy. Up to August 2021, the worldwide government has dumped $52.2 billion of money assistance in order to keep the airline afloat. Government aids, which come in various forms of guarantee loan, direct cash injections, and web subsidies, has rescued several airlines temporarily from falling into bankruptcy. Industry loan has sky up $430 billion in 2019 to $650 billion in 2021. The huge amount of debt crippled the airline planning for route expansions, fleet modernizations, and rehiring processes. as bitter as pill to swallow, government should consider cancelling or restructuring the airline debts to ensure that the industry has a stable and secure balance sheet to kickstart its recovery. Noting the prominent role played by the airline, it will be solid investment for individual government looking to boost economy. In larger picture, each airline's job saved will support another 24 jobs in a broader economy. Maintaining the airline networks and connectivity and the pool of jobs of skilled professionals are pivotal if the aviation is expected to contribute to strengthen the global supply chain to successfully offset the economic prosperity. These are some of the steep infrastructure costs that increases, which is not doing any good to the airlines. These are more examples of the fund that has been used to support the airlines throughout the periods. And other intangible assets such as route, time slot, form the intrinsic value of an airlines.
Keith.
Yes.
Yeah, very informative information, but unfortunately we are out of time.
Yes.
The next session was supposed to start about 5 minutes ago.
Okay.
Could you do a quick wrap up?
Okay, all right. Sorry about that. Just... Sorry. I'm very sorry. We actually, because of the time factors, we have to come to the closing part. So, ladies and gentlemen, okay, as a engineering and technologies practitioner, we must understand the economic values of our innovations, idea, and creativity, so as to market our invented products and services. The aviation industry works in a circular economy in an example of a push-pull analogy and a symbiosis relationship between the designer and the airline. In short, we must practice entrepreneur mindset. Okay, with that, if there is any questions, I hope I can answer you or anything from the floor.